mountains of northern California is at the cutting edge of the search for intelligent life. Its aim to scan the skies 24 hours a day, every day of the year, in the hope that it will tune in to messages from alien civilizations. Human ingenuity is bringing us closer and closer to understanding the cosmos. But of all the questions, one, perhaps the biggest one of all, remains unanswered. Are we alone? Is there other life out there? Some of them are looking for incredibly primitive life, really quite close at hand, and others are looking for something you could talk to. In this program, we'll meet the godfather of extraterrestrial hunting. We'll be putting a little experiment into outer space, and we'll be asking, if aliens get in touch with us, how will we respond? This is the Allen Telescope Array, or ATA for short. It's still under construction at the moment, but when it's finished, it will dramatically improve our chances of finding alien intelligence. Dr. Seth Shostak is an astronomer with over 20 years of alien hunting under his belt. He's integral to the development of the ATA.
This is an array. In other words, it consists of lots of little antennas instead of being one giant. Right. And there's some advantages. Well, to begin with, it's a lot cheaper to build lots of small things in one giant. And being an array, it can also speed up our search because we can look at more than one thing at a time. So that's one.
You mean they're all pointing in different directions?
No, most people would figure that, but that's not what to do. They all work together. This is really a theme of telescopes. Right. They're always pointed in the same direction, but in that direction they can be looking at different things simultaneously, more than one star system at a time.
Set plans to hone in on stars that have the best chance of having Earth-like planets. The strategy is to start with our closest stars and work further and further out into space.
We have looked at fewer than 1,000 stars very carefully. 1,000 star systems, that's not many, given that there are 100 billion in the galaxy. And once this is up and running, this instrument should be capable of checking out on the order of 1 million star systems. I think that's the right number. I think we can check out 1 million. We have a good chance of checking the right number.
The ATA is revolutionizing the hunt for alien life. Once complete, there will be 350 dishes crammed into an area barely 1 kilometre square. And there are even more exciting plans in the pipeline, an international billion-dollar project to build the world's largest telescope, the Square Kilometre Array. This telescope will have thousands of dishes and a central collecting area 5 kilometres across, and will be so powerful it will tune in to the formation of galaxies at the very edge of the universe. It's planned to be up and running by 2020. San Francisco, California, famous for the Golden Gate Bridge, trolley buses and earthquakes, is also home to a very special organisation. This is the headquarters of the SETI Institute, responsible for building the ATA. SETI stands for Research for Extraterrestrial Intelligence. In our galaxy alone, there are 100 billion stars, and we know that many of them, in fact most of them, have planets. Since there is intelligent life on one planet, this one, the founding fathers of SETI reckoned there must be a reasonable chance that there's intelligent life elsewhere as well. Now, if there are aliens out there, then they may be trying to send us messages. And all we have to do is listen. Well, SETI has been listening for more than 40 years now, and I've come to meet their leader. In 1960, SETI launched Project Ozma, pointed a radio telescope at 2 nearby stars, and listened. It didn't take long before a signal arrived, to comfort an American U-2 spy plane. But the project had put SETI on the map, and in 1961, scientists gathered to assess seriously the chances of detecting intelligent life. Chairing that meeting was one of the founding fathers of SETI, Frank Drake.
I invited every scientist in the world who I thought was interested in the subject, all 12 of them.
It was at this meeting that Frank introduced a now famous equation, one that has become the foundation for many discussions about the hunt for intelligent life.
I, of course, spend a lot of time thinking about the subject of how many civilizations are there out there? How hard is it going to be to find them?
There are 7 variables in Frank's equation. Some are reasonably well known. Our star, for example, is the number of stars born each year in the galaxy. FP is the fraction of those stars that have planets. But other factors are more educated guesses than serious science.
FC, FC is the fraction of intelligent species which develop the technology high enough that we can detect it.
So communication.
Right. And L.
L is the longevity, the length of time these civilizations stay detectable on average.
By multiplying all the factors together, Frank was able to estimate the number of detectable civilizations in our galaxy.
What's the answer? What is N?
Value N is based on some very uncertain factors in the equation, but my enlightened guess is 10,000.
10,000 civilizations in our galaxy who could talk to us right now. If there are 10,000 in our galaxy, how many are there in the whole universe?
In the entire universe, there are 100 billion other galaxies. So the total number of detectable civilizations is 100 billion times 10,000. You can work that out. A very big number.
That's a very big number.
But remember, our galaxy, the Milky Way, is so vast, it would take us 100,000 years to cross it, and that's traveling at the speed of light. And our galactic neighbor, Andromeda, is 2 million light years away. Even though Frank's estimate is big, it's a big universe with tons of potential for harboring aliens that could get in touch. But not all alien life will be intelligent or have the ability to communicate. So, our search for life takes 2 very different paths. On the one hand, we're looking for sophisticated creatures capable of sending messages over vast distances. And on the other, we're looking for the very simplest life forms. But where should we look? The pretty seaside town of Fear in Devon is probably the very last place you'd expect to find life similar to that which could exist on other planets. But for astrobiologist Professor Charles Coppell, this beach on the south coast is home to a form of life you could expect to find on alien worlds. With the help of the European Space Agency, Charles plans the ultimate endurance test for these creatures, a journey into outer space.
You tip off some of this, you can see these green layers of microbes actually underneath the rock surface.
Bombarded by the wind and the rain, these fish see the very worst of the British weather. But that's not the only problem for these microbes.
The sea washes in the water into the rocks, and then the water begins to evaporate. You get very, very high salt concentrations. But also on the surface of the rocks, they're being constantly exposed to sun's rays, which can be damaging to them.
These cliff dwellers are cyanobacteria. They're part of a special group of organisms called extremophiles.
An extremophile is generally a word for microorganisms that live in physical or chemical conditions that are much more extreme than you and I are used to. People have found them growing at very low pH, that's very acid conditions, very alkaline conditions. They can grow at high temperatures. They can grow in the freezing ice sheets of Antarctica.
But what does this mean for the chances of life evolving in extreme climates on other planets, like Mars?
Well, you wouldn't necessarily think that a small village with fishing boats is analogous to some sort of environment on Mars or some other extreme planet. But in fact, it's rather interesting because inside these rocks, they're being exposed to very high salt concentrations. Rocks with high salt concentrations seem to be a very common phenomenon on Mars.
So, there's an interesting link between the microclimates here in Devon and conditions on the Red Planet. But Charles's interest in these creatures doesn't end in Fear. As part of the Biopan mission, he's sending these cyanobacteria into space. There, they'll be subjected to extreme temperatures, to high-energy particles streaming in from the sun, and the damaging ultraviolet radiation.
So these are lucky microbes that I've selected. When we get up into orbit around the Earth, the top of the spaceship opens up and the samples are exposed to the conditions of outer space for 16 days. And then the spaceship closes up again and the samples return to Earth.
If Thea's extremophiles can survive inside space and in outer space, there could be every chance similar life forms could be living on Mars, if we look in the right place. Although only half the diameter of the Earth, the red planet has a great variety of geological features, from huge volcanoes to enormous canyons. So, where will we look for signs of life? And when we get there, what will we do to find it? We sent Janet Sumner on a mission to the Space Research Centre in Leicester to find out more about a brand new technique to detect life on Mars.
ExoMars is the European Space Agency's next big mission to the red planet. Its main aim is to look for life beyond Earth, and it's challenging scientists to come up with some pretty amazing experiments. Dr. Mark Sims is one of these scientists. Mark is no stranger to Mars. As mission manager on Beagle 2, he came close to success. But now he's turning his attention to ExoMars, a mission to the red planet due to be launched in 2012. On board will be Mark's state-of-the-art detector, the Life Marker Chip.
The Life Marker Chip is very much a merger of space research and biotechnology. We're looking for very basic life. We're looking for bacteria, if you like, microorganisms, because, to be honest, that's going to be the dominant life form on any planet. On the Earth, for example, over 90% or 95% of all the living mass on this planet is actually in the form of bacteria.
The marker chip is also looking for evidence that life once existed on Mars. It will attempt to find a substance called kerogen. All living things turn into kerogen after several million years. It's a byproduct of death. So, how will ExoMars get the samples?
ExoMars is unique because it has this drill on board which can drill down into depths of 1.5 to 2 meters. Now, if we're looking for signs of life on the planet, it's probably the depth we'll actually find that evidence. Essentially, what we're trying to do is we're trying to get away from the hostile conditions on the surface of the planet. The ultraviolet radiation which hits the surface of Mars will give you a total of 7,000 nanoseconds. If we really want to go look for signs of life on Mars, we're probably only going to find those signs 1 or 2 meters down.
On ExoMars, the Life Marker Chip won't be looking for visible signs of life on the Martian surface. It works at a molecular level. But what does that mean? Well, let's get back to basics. If this toy represents the marker chip, then these coloured holes, triangle, square, circle, hexagon, represent molecules that indicate life on Earth. They act as the detectors on the marker chip. Now these A, B, C blocks, let's say they're molecules from Mars. If one of them passes over the marker chip, nothing happens because it doesn't fit and there's nothing to indicate the presence of life. But in another sample from a different part of Mars, there could be other molecules, and if one of those passes over the chip, bingo, it fits perfectly like a lock and key, and it's the bond that's created that indicates the presence of life. The brilliant thing is that no matter how rare these life molecules are, if they are in the sample, the chip will find them. Dr. Dave Cullen, a biotechnologist from Cranfield University, has teamed up with Mark Sims to create the groundbreaking technology needed to make the Life Marker Chip work. His inspiration comes from a surprising thought that has something to do with detecting early stages of human life. A pregnancy testing kit.
And this is it. This is the pregnancy testing kit that's going to go to Mars, is it? Or something like this?
Something like that. They're some test pieces that we're working on at the moment in the laboratory. There will be 4 panels.
Yeah.
Each one of those could be equivalent to a high-tech protein testing kit.
The Life Marker Chip will have hundreds of these test channels. For each measurement, water will be spraying through the soil, a bit like a coffee machine, then the sample deposited on the chip.
And if you get a hit, what will it look like? What will you see?
So what we'll see within these panels will be spots that will glow or don't glow depending upon whether the microorganism has been uppresent in that sample.
Right. There's glowing spots over here. Is this what it would look like then?
Yes, that's obviously at a much larger scale, so it's just a demonstration. But that's the kind of thing we see.
So in essence, if you've got glowing spots, you've got life.
So
sympathy.
If you do have a positive circle, what kind of implications do you think that has for finding life elsewhere?
Oh, it's immense. At the moment, we know life exists on Earth, and we have no evidence whatsoever of life anywhere else in the universe. If we go to Mars and find evidence of life, then of course that starts to tip the balance and suggest that it's commonplace.
So, we found life in extreme environments here on Earth. We're developing technologies to detect primitive life on other planets. But if we find life out there, what will it look like? Most fictional aliens look pretty much like us. But who's to tell how creatures on other worlds will adapt to their environment? Life may not be carbon-based like on Earth. It could be based on silicon or even nitrogen. Aliens with these life chemistries may be so different that we wouldn't even classify them as living. But this isn't putting the alien hunters off. Some life could be primitive, but there's a chance that distant civilizations are trying to get in touch. At the APA, the enormity of the task facing Seth Shostak is dawning on me. How long will it be before he strikes gold and tunes in to an alien broadcast?
You monitor 100 million channels at once. In fact, what you see here is an actual display of some data coming in. Here's the low end of the dial, here's the high end of the dial. And you see all the cosmic static here, this sort of sprinkly stuff. But you also see this line here, and that bright line, that's a real signal. But it's coming from a known satellite. It's, that's human technology, but we look at those occasionally just to check out the system.
Have you ever had a signal that you thought was real?
Occasionally you get signals that for a period of hours even look like they might be the real deal. And that's kind of instructive because it sort of shows how you would react if you actually think that was real. Keep it very nervous.
Radio telescopes like this are great for us to listen to them. But can they hear us? Well, human beings are noisy. Television signals have been leaking into the cosmos ever since the first broadcast went out 70 years ago. If the aliens out there are watching our television, what are they going to see? Oh. Picture the scene. You've got a nice cup of tea, you sit down, you put your feet up, you switch on the telly, and you're watching this program. Now, this program, like all other programs, is broadcast not just into your home, but also into space. Suppose there are aliens out there, and suppose they're tuned in to Channel Earth. What are they going to be watching at this very moment? Well, TV signals travel at the speed of light. That's 186,000 miles every second. And the nearest star is Proxima Centauri, and that's 4 light years away, 25,000 billion miles. It takes light 4 years to get there, so it takes TV pictures 4 years to get there. And that means that if there's anyone out there watching, what they'll be seeing are these extraordinary pictures of Saddam Hussein's statues in Tokyo, broadcast to millions around the world in 2003. Let's go a bit further out. Let's go to Altair, 17 light years away. They'll just be getting the glad news that Nelson Mandela has been released from jail. Broadcast in 1990, but it's taken 17 years to get there. That's what they're watching now. With their all-way-now-to the twins, Geminis, is past their 42 light years away, and they'll be getting Beatlemania, because here are the Beatles getting their MBEs at Buckingham Palace in 1965. And now 71 light years away, they'll be seeing the first ever public broadcast of a major event. This is the 1936 Olympic Games, and they'll be watched by Adolf Hitler. Isn't that extraordinary? Now these may be the first pictures that any alien see of Earth. It's a rather curious first impression, isn't it? And now I'm going off to the red supergiant on the right shoulder of Orion. This is Betelgeuse. And out there, all they'll get is a fuzzy screen. It looks like snow because those signals are still hurtling through space. If they want to watch this program about the cosmos, they're going to have to wait 425 years for the signals to get through. Although television signals have been leaking into space, they're pretty weak, and they're not targeted at any particular star system. But has a direct, constructive message ever been beamed into the cosmos?
In 1974, we sent a signal on purpose using the World Horizon Telescope at Arecibo. That signal was brighter when it was sent than our sun. Not by a little bit, by 1,000,000 times.
Frank's message was in binary code. It contained symbols for the human body, DNA, the solar system, and the Arecibo dish itself. It's not the only time we've tried to contact aliens. Launched in the 1970s, each Pioneer and Voyager spacecraft had a plaque on board which told any potential alien who we are and where we come from. Suppose we do discover intelligent life out there. What then? Do we try to make contact? How do we make them understand us? And what do we say? Guy McCosh is in charge of the Interstellar Message Composition Group. It's his job to work out how we would communicate with aliens. If SETI strikes gold with a signal, how exactly would he reply?
ET is not going to speak English or French or Swahili or what then matters as common language. Mathematics is the language of choice because in order to create the technology to communicate, you need to know at least some basic math. A great example is the Fibonacci series. You simply start with the two most basic numbers, 0 and 1, and keep on adding them together. So 0 plus 1 equals 1, 1 plus 1 equals 2, 1 plus 2 equals 3, 2 plus 3 equals 5, on and on into infinity. It's simply a series of numbers that can be encoded as a series of pulses. Now, the great thing about that series is that the numbers that you find creating that series are found everywhere in nature. And you find them in the structure of spiral galaxies. You see them in the branching patterns of plants, in the number of petals on various flowers. Certain proportions that we judge as being beautiful. The very spiral of a nautilus shell, you see from the outside or from the inside, is intricately connected to this Fibonacci series.
We think we're getting closer to understanding interstellar communication, and we have the technology to convert our receivers into transmitters, capable of sending signals deep into space. So why are we still waiting for the aliens to contact us? Can't we be the ones to pick up the phone and dial?
By listening, we could succeed tomorrow. If we transmit and then wait for a reply, it's guaranteed to be decades, even centuries before we could succeed. But what if everyone is listening? I think we should start transmitting in a very serious, systematic way. It takes a young civilization, an audacious civilization, to make the first attempt at transmission, and perhaps that civilization should be us.